Hi everyone, this is the first video of many that's going to be reviewing your EOC packet that's going to be due on Thursday and Friday of this week to prepare us for our EOC on Monday and Tuesday, May 1st and May 2nd. So the directions are: copy down all the diagrams and show all of your work in order to get full credit. I'm going to go through every question. Before I get started with the question, make sure that you've read through it and you've tried it out, because I'm going to go right into solving it. All right, so here's our first question. So they gave me angle 5, which is 112 degrees. And my goal is to find the measure of angle 15. Now, what I told you about these diagrams that have parallel lines cut by a transversal is that all acute angles are going to have the same measurement. All obtuse angles are going to have the same measurement. And if you have an acute angle and an obtuse angle in a diagram, they're going to add up to 180. Now this diagram is a little bit more special because we have two transversals, but because the two transversals are also parallel, line C and D, then this rule is still going to apply. So if I take a look at angle 5, it's 112 degrees, and angle 15, it's also an obtuse angle based on the diagram, so it should have the same measure, and I'm going to say that the measure of the angle is also 112. Now, if we wanted to be more specific as to why it's 112 degrees, we can take a look at it like this. Angle 5 and angle 13 are corresponding angles, so those should be congruent. So angle 13 is also 112. And now that angle 13 is 112, now I have line C and D with this transversal B creating some relationships between angle 13 and 15. Angle 13 and angle 15 now are also corresponding angles with respect to line B as its transversal. So those two should also have the same measure because they're both corresponding angles. So that would be the official reason as to why they're both 112. All right, let's move on to the next question. All right, now in this question, as soon as you see that it's a right triangle, you need to think about Pythagorean theorem, trigonometry, special right triangles. So in this case, we're not trying to find a missing side length when we already have two. In this case, we only have one side length and one angle, which means we're going to use trigonometry, trig. So when we use trig, we start off by taking a look at our reference angle, which is 27 degrees. We label in opposite, adjacent, hypotenuse. In this case, we don't have the opposite, we have no information about it, and we're not trying to find it, so we're not going to use O. We have A and H, which according to So, Ka, Toa, means we're going to use Ka, cosine. So let's set up our trig function here. Cosine of our angle, in this case it's 27, equals the adjacent side, which is x, over your hypotenuse of 12. Now, when you have the numerator of your fraction being a number, to get rid of that numerator and to get your final answer for x, we're going to multiply both sides by 12. So the 12s here cancel. And now we're going to do in our calculator the cosine of 27 times 12. So grab my calculator here. 27 cosine. It's that decimal there, times 12. And I get about 10.69. So I'm going to write down that x equals 10.69. The question asks you to round to the nearest tenth of a unit. The tenth is the first place, the first decimal place. So the 6 has a 9 afterwards. The 9 tells me round up. So it's going to be 10.7. All right, next question. The floor of the gazebo in Damon's yard. We're trying to cover it, trying to cover this floor. Now, if we're trying to cover it, and the question says, how many square feet of carpeting do you need? Anytime we see square units, feet squared, inches squared, anything squared, we're talking about area. So the question here is, what's the area of this regular octagon? To be regular means all of the sides have the same exact length, and all of the interior angles are going to have the same measurement. Now in this case, the two pieces of information they gave me, they told me that each side was going to be 8 feet long. If one side's 8 feet, all of them are 8 feet. So I'm going to label that in. The next thing that they told me is this apothem. The apothem we've learned about starts from the center of your shape and it's perpendicular to a side. And when it cuts into that side, it's going to cut at the midpoint. So it's going to cut your side in half. They told me that the apothem is 9.7. Now what we learned about regular shapes, any regular shape can have its area found using the formula A equals 1/2 apothem times perimeter. So the only two things we need is the apothem and we need the perimeter. Now we're pretty lucky here because we have a lot of information. We don't have to do any trigonometry in order to solve for either the apothem or for the perimeter. We have the apothem. They told us it was 9.7, so I'm going to put that into my graphic organizer. And then the perimeter, since I have 8 sides and each side is 8 feet, 8 times 8 is going to give me the length of the perimeter, the outline of the shape. So 8 times 8 is 64. So in my calculator, I'm going to type in 1/2 times 9.7 times 64. Or if we do 9.7 times 64, then divide by 2. So my answer is going to be 310.4 feet squared. And let's see if any of my answers match up. Yep, F, 310.4. All right, next question. All right, now in number 5, they're asking you to solve for the volume of this cone-shaped reservoir. Now our volume formula, we're going to write it down. V equals anything with a point, this thing called an apex, a point, is going to be 1/3 big B H. Now one thing I keep driving home is that this big B is not a single number. It's the area for your base, the platform of your shape. In this case, our base is in the shape of a circle. So when we find the volume of this shape, we need to find the area of the circular base, and that's going to be our big B. Now, with these volume formulas and surface area formulas on your EOC, they're never going to make it easy for you. They're always going to make you have to solve for something that you need in the formula. Maybe it's the height, maybe it's the radius, maybe it's the slant length, but something. So don't expect that these problems are going to be easy and that you're going to be given everything that you need. All right, you're always going to have to find something. So let's take a look at this one and see what we're missing and what we need to find. Okay, so I need to find the height. Let's start there. This 13 feet, that is not my height. That's the slant. That's this portion here. So that's where it gets tricky. I need to solve for the height. The way that we do that with most of these problems, it's going to be to draw in a right triangle and use either trigonometry if I have an angle or Pythagorean theorem to solve for whatever side length is missing. So let me go ahead and draw in my right triangle. I'm going to draw that height on the interior of my cone. So I formed 2 right triangles back to back. I'm just going to pay attention to one of them. So I'm going to pay attention to this one on the right. And I'm going to solve for that missing height. Now, when I drew in that height, it cut the top of my circle, that base, into 2 radii back to back. So I have a length of 5 for the top portion of my right triangle. Now, I'm going to use Pythagorean theorem. Careful here, because our C value in the Pythagorean theorem, our C is going to be the 13. And the H, the one that we're looking for, that could either be A or B, it doesn't matter. So let's go ahead and set that up and solve. 5 squared plus H squared equals 13 squared. 5 squared is 25 plus H squared equals 169. Subtract 25 from both sides, so H squared is 144. And then square root it, because I just want H. And H is 12. So my height here is 12. Great. Plug that into my formula. Height is 12 feet. Now, let's substitute in what the big B is going to be. Now, big B is going to be this formula for the area of the circle. So it's going to be pi r squared, bringing down the 1/3 as well. The radius of my circular base is 5. So I'm going to plug in 1/3 times pi times 5 squared times 12. I'm going to simplify the 5 squared, so it's 1/3 times pi times 25 times 12. Now we're just going to plug this into the calculator. Now be careful, in these problems in your packet, they're asking you to use 3.14 instead of the pi symbol. On the EOC, unless they specify, you're going to use the pi symbol, and you're going to get an exact answer. You're not going to use 3.14. But here it specifies to use 3.14. So let's get started. In the calculator, I'm going to start, and I'm going to start going backwards. I'm going to start from the 12, and I'm going to work my way back. So 12 times 25 times 3.14. I get this number 942, and then I need 1/3 of that, so I divide by 3. So I get 314 as my volume. 314 feet cubed. Anything to the 3rd power, that's volume. Okay, so here I have choice C. All right, here we're picking up from number 6. Now, this question is asking you which of the following guarantees that the two triangles in this big triangle are congruent. In order to guarantee that two triangles are congruent, we need to use one of our theorems. Our theorems to prove triangles congruent are side, angle, side, 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 angle, side, angle, 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 side, and a special one just for right triangles. If you have the hypotenuse and the leg congruent, you can use HL. But that doesn't mean that you always have to use HL if it's a right triangle. So we need to take a look at what information we do have as to what is congruent from the information presented in the prompt. And then we need to think, okay, which of these additional pieces of information allows us to prove that the two triangles are congruent using one of our theorems. So before I even get started, I'm going to take the two triangles they're talking about, I'm going to break them out. Now this is a hard question, so I'm warning you, okay? I'm going to break out the two triangles and we're going to come back in a second. Okay, so here I've broken out my two triangles. Now I've shown that the two right angles are congruent because they gave me that in the diagram. Now the other thing they give me in the diagram is they basically tell me that angle S, since it's an angle that they share, is a second pair of angles that are congruent here. So I'm going to mark that up in my two triangles. So right now I have two sets of angles congruent between the two triangles. I probably need a side length here. Let's see what they give me. I'm going to start with the bottom problem, I, or rather the bottom choice I. They tell me Rx is congruent to Ty. From R to X, that's right here, and T to Y, that's right here. Well, that's only going to be like a little piece of my line segment. That's going to be like this little piece here, and then this little piece here. That's not going to give me a whole side, so I don't want that choice. And I'm going to erase that from my diagrams. I'm going to cross that out. I don't like that. Next one, angle RTX, so from R to T to X. Okay, that's this little angle here. Is congruent to TRY, try. Okay, this little angle here. Now those two angles aren't even part of our two triangles, so I don't want to use that. I'm going to cross that out. Now the next one, line segment RO is congruent to TO. All right, let me find that. RO, okay, and TO. Again, that's like two little pieces of the whole side. That would be like this piece here and that piece here. That's not even a whole side, so I don't want that. So I'm going to erase that. So I'm crossing out G. Now the last choice, and this is tricky, it tells us that, let me erase what I have. It tells us that angle R, this whole angle here, is congruent to all of angle T. Now usually I would say no, but because of this being an isosceles triangle, if those two angles are congruent, that means the entire left side is congruent to the entire right side. So in our diagram, we have a set of sides congruent. So this would be angle, angle, side. So yes, angle, angle, side is a way to prove congruent. So